my name is Josh Hickman, and today I'm going to be talking about the Android Find My Device network, not to be confused with iOS's Find My network. But before I get started, just a few bits about me. Currently, I'm at Celebrate. I'm one of the digital forensics experts on staff there. I've been there for a little bit over a year and a half now. Prior to that, I was in consultancy at a company called Kroll, mainly dealing with ransomware and network intrusion type events. I have a colleague back there, Tony Knutston, who worked there with me. Before that, though, I was in government service for almost 20 years. Most of my time was with the North Carolina State Bureau of Investigation. I started out working homicides and public corruption cases, but eventually made my way to the Computer Crimes Unit, and I was attached to the Internet Crimes Against Children Task Force. In my spare time, I do blog. I maintain the Binary Hick, and for those of you that may have visited it at some point, thank you for visiting. Hopefully you found something that was useful. So again, Android's Find My Device network. Now, you're probably wondering to yourself, why are we talking about this? Because Find My Device has been around for quite a while now, and Bluetooth tracking tech has been around even longer. It's well over a decade old. But the reason we're talking about it is because last year at their annual I/O conference, Google said, we're going to open up Find My Device to Bluetooth trackers. And at the time, there was a lot of controversy surrounding still AirTags and Apple and how they handled that rollout and some of the safety issues that introducing those devices brought about. And so Google actually did something unusual for them. They waited a full year to roll out this functionality to Find My Device. During that time, they collaborated with Apple. They came up with a public spec. So that way, there was an understanding between the two platforms, iOS and Android, on how to handle unwanted trackers. And so during that time, that specification was written up. And then earlier this year, individuals started getting emails from Google saying, hey, your devices are getting ready to be enrolled into Find My Device. And this is one of the articles on the right. That's actually the email that I got from one of my test accounts. But for the uninitiated and how this kind of aligns with what we already know, there are some similarities between the two. Apple has Find My, and Google now has Find My Device. I will try to not mix those two up during this presentation. There are AirTags on Find My, and for Google, you have whatever third-party manufacturer is willing to manufacture for Find My Device. Right now, there are only two hardware manufacturers that are creating or manufacturing Bluetooth tags. That would be Chipolo and Pebblebee. I went with Pebblebee for testing, which you'll see in just a minute. So we've got some similarities, but that begs the question, are we going to have similar outcomes? The article that you see there references an arrest that was made on an individual who is using AirTags for nefarious purposes. That is actually from a couple of months ago. We're still seeing these type of articles. And so that begs the question, are we going to see these type of articles for Find My Device, Bluetooth trackers? And we just don't know. The functionality has only been around since May, so not very old. And hopefully we won't see it, but more than likely we're going to see some type of nefarious usage. So considering all that, I wanted to take a look at what is left behind on phones that interact with these Bluetooth trackers on Find My Device, both a device that is the owning device, but also a device that has been followed by a tracker, an unwanted tracker, if you will. And so for this, I have several devices that I used. The Pixel 5a, 8a, Pixel tablet, and the Chromebook were all on the same Google account. Now I'm going to go ahead and remove the Chromebook from this list because you will not see it again. These, as far as my testing went, does not appear to be part of the Find My Device network yet. That could change in the future, but for right now, you will not see these on Find My Device. The two Galaxy devices, the S22 and 23, those each had their own individual Google accounts. And then I've got the iPhones here in the mix because As of iOS 17.5, these can now detect unwanted trackers that are operating on the Find My Device network. Each one of these devices was running the most up-to-date version of their software at the time. As a side note here that's not on the screen, the iPhone 14 Pro is actually running iOS 17.6.1 at one point during the testing. So very up to date. This is the tracker that I chose for testing. This is the Pebblebee clip. Pebblebee makes these trackers in various form factors. There's another one that they manufacture right now that can actually slide into your wallet. It's about the size of a credit card. But a couple of things to note about the hardware itself. On the left, that is the front of the tag. And you notice that there's a Pebblebee logo in the middle. There's actually a physical button underneath that. Clicking that button in different sequences actually causes the tracker to do different things, which you'll see in a little bit. On the right, that is the back side of the tag. And I know it's kind of hard to see, but there is a serial number and a MAC address. You can go ahead and forget those because you're not going to see them again at any point during this presentation. Out of all of the data that I looked at during testing, I never saw these identifiers in the data. When I go to pair one of these trackers, going from left to right here, I simply double-clicked the button. That brings up the card that you see, and it says, hey, I'm here. The phone automatically detected it. I didn't have to do anything specifically to the phone. The next screen, that's basically saying, hey, don't use this for badness, okay? Cool. Agree and continue. And then the pairing process starts with the phone. And that results in the screenshot that you see on the far right. In order to manage your devices on Find My Device, you actually need the Find My Device app. This is not something that is installed by default on Android. Regardless of what OEM you have to go out to the Play Store to get this app. So keep that in mind, if you're trying to determine whether or not somebody's, well, I didn't know that tracker was there. If that app is there, they've got some explaining to do. Once you get the tracker onto your phone and associated with your account, on the left, you can see that's the device dashboard. That's just simply a listing of all the devices that you currently have on your Find My Device account. In the middle, that's me tracking the Pixel tablet. And now, interesting note about that device, and really any device that has Wi-Fi capability, if the device that you're tracking has the ability to connect to Wi-Fi and it is connected at the time that you locate it, you will get the SSID back as part of the information that you see there. So that could be really helpful when it comes to trying to identify a location where that device may be. On the right, that is the Pebblebee clip, and that's just me trying to locate it. And when we talk about these trackers, owners have several options that they can, or several things they can do to these trackers. On the left, you can see that's me renaming the tracker. So when I paired the tracker initially with the phone, Android just assigns a default name to it, but I can always go back and change that later if I want to. I can assign it to a category, and these are predefined categories for Find My Device. If I say, hey, this is on a set of keys, I can say that's a key, and then the icon changes, and then the user, from there on out, you can just follow your keys across the map if you lose them. I can mark a device as lost. And so what that entails is when I mark a device as being lost, I can add my contact information. That way, if someone finds it in the wild, they can scan it, they can see my contact information, and hopefully reunite me with my lost item. On the right, you can share a tracker. And I'll talk about that in a few minutes because there are some forensic implications to that. Speaking of which, let's talk about the forensics. And I'm going to premise this part of the talk with this sentiment. This network is not in really good shape at this point. If you can do a quick Google search and find people complaining about the lack of reliability, the lack of updating, the lack of just general performance with this network. And as it turned out, my experience mirrored a lot of what you will find online. And Google has heard this and they're saying, well, it has a lot to do with this right here. This is the default setting for a phone when it's part of the Find My Device network. This setting puts two requirements on a phone before it will report back to Find My Device any tracker that it's seen. The first requirement is that the phone has to be in what they call a high traffic area. And Google defines that as something like an airport or a busy footpath. But you can also think of like a shopping mall, a busy office complex. If you're stuck on the 405 in California at rush hour traffic, that would also count. But Google says this is part of the problem. So what they're recommending to users is to change the setting to this. What this does is it actually removes the requirements for that. And I forgot a requirement. There's a second requirement to this. It's called aggregated detection. More than one Android device has got to detect the tracker before it will report back to Find My Device. So busy area, multiple devices. Changing the setting to this actually removes those requirements. So in theory, if a tracker's in the middle of a field and I'm the only Android device that sees it, theoretically, I should report that back to Google, but my experience with that was actually not very good. It didn't really do that a whole lot. So trackers are they use the Google fast pair service. And so we're talking about Bluetooth here. And the files that we normally use in Android forensics to identify Bluetooth connections just aren't really helpful with these devices. Things like BT_config and Bluetooth_DB. You're not going to see information about these trackers in those locations. So thinking outside of the box a little bit, there is a file as part of Google Mobile Service that describes fast pair devices that have been seen by a phone. The first one is nearby fast pair item cache.db. That's a very long name. This is not a SQLite database. This is a level DB. So to render this for you for this presentation, I'm using a tool called Mushy, which is written by my colleague at Celebrate, Ian Whiffen. It's free. You can run out to his website and download it. But just know that, for those of you that are not familiar with level DB, just know that they operate on a key value pair. And as far as this is concerned, the key is the MAC address of the Bluetooth or of the tracker at the time it's paired with the phone. But as it turns out, that MAC address is also part of the value that's associated with this key. And I've got that highlighted here in the red. That's simply the MAC address at the time of pairing. The reason I keep saying that is because just like AirTags, trackers on the Find My Device network utilize Bluetooth MAC randomization. The specification that Apple and Google wrote state that a tracker's MAC address should rotate every 24 hours. It doesn't preclude it from rotating more often, but that's just what the spec says. Further in the value, I've got two things highlighted here in the blue box. That is the friendly name or alias of the tracker at the time it's paired. If you recall, Android will assign a name to the tracker, but a user can always change the name later on. You will not see the change name here, but simply the name of the tracker at the time it was paired with the phone. The next thing just below that in the red box, there are two Unix epoch timestamps there. In my testing, these epoch timestamps were never exactly the same. They were usually a second or two off, but they are indicative of when the tracker was paired with the phone. And in situations where you're not really familiar or you have a question about what this device is that you have in your hand, in the value, Google includes a picture of what it thinks it is, and this is simply just the picture that shows up when you go to first pair it. So that could be handy in situations where there's a question about whether the hardware that you have in front of you is actually the thing that the phone thinks it's all. A couple of notes about this file. First, if a tracker becomes disassociated from the user's account at any point, you will still find information about this tracker in the file. One of the trackers that I used for testing had been associated from day one, so back in June. And up until I flew out here yesterday, the information about that original tracker was still in this phone well after I had disassociated from the account. So just keep that in mind that you could find that information still present in this file. However, that being said, it does have a cache in the file name, which kind of lends me to believe that this is still temporary, but I don't have a good answer for you as far as shelf life on the type of, or of the information in this file, so just keep that in mind. There is another file in the same file path, just has scan added to the file name. There is duplicate information in it that we saw previously. The next file I want to talk about is one that was actually very surprising to find. It's called Maestro_devices. It's a single SQLite database that is part of the app that is used to manage Pixel Buds, which is kind of strange to me, but okay. But I found it on my Pixel phone, but just keep in mind that any Android device can be paired with a pair of Pixel Buds. So just because you don't have a Pixel phone in front of you doesn't necessarily mean that this database is not there. Now, you basically were getting a replay of what we saw in the nearby fast pair file. And just to show you that, I've got that file just below it, but the database has got the same three things: the MAC address of the tracker at the time when it was paired with the phone, a timestamp that doesn't really match either one of those unique epochs timestamps, but it's still within that time to the point where it is indicative of when the tracker was paired with the phone. And then I've got the name of the tracker at the time of pairing. So again, just another place that you can go to get the same information that we saw in nearby fast pair. The next file is one that is exclusive to Samsung devices, and it's inference engine logging.db. This is part of Samsung Rubin, and for those of you that may not necessarily be familiar with Samsung Rubin, it is the equivalent of Knowledge C on iOS. It tracks a lot of user activity on a Samsung device. Now, this database actually is encrypted, and so you're going to need a full file system extraction to get to it, but you're also going to need the key from the key store to decrypt the database. So whatever you're using to do your extractions, just make sure that it's also able to get the key out of the key store, else this information is not going to be available to you. Again, this is tracking a lot of things, but there are two things that we're in particular that we're wanting to see. The first table is all Bluetooth dictionary, and this simply is just a database of Bluetooth devices that this phone has seen during its lifespan. You see the MAC address there. I've got the alias, the friendly name, and again, that's just what it was at the time when the phone was when the tracker was paired with the phone. And then all the way on the right, I've got a created at timestamp column, and the timestamp again is indicative of when the tracker was originally paired with the phone. The next table is all Bluetooth log. This one is interesting in that it really shows the effect of Bluetooth MAC randomization. I filtered this table by the MAC address, and I only had 4 hits, 2 connection events and 2 disconnection events. The timestamps are all within 20 seconds of each other. And again, this was when this tracker was paired with this phone. I don't see this MAC address again. Even up until yesterday morning before I left to fly here, that MAC address was still only in this location. It didn't appear anywhere else. So the MAC randomization is really going to cause havoc and give you a major headache when you're trying to match a tracker with a phone. But the good news is that there is help available, and it's by way of Google. Talking about takeout data or search warrant return data, you will find information about associated trackers in this data. Now, this is the takeout data from this particular account. Trackers are considered to be home devices, so the home app.json file and its warrant return equivalent will hold this information for you. There's 3 bits of information in here that are important. First, in the red box, I've got the timestamp, and that is the time at which the tracker was associated with the Google account. At the bottom, I've got the user-defined name, and that is the name that I've given the tracker. If I take the default at initial pairing and then I opt to change the name of the tracker later on, I will see the new name here in that green box. So whatever the current name of that tracker is, it will be in that field. The value in the blue box is actually really interesting. It's called a ring key. It is a alphanumeric string. It's actually 8 bytes. I found out later on. It's a quasi-unique identifier for the tracker, and we'll talk about why that is the case here in just a few minutes. I mentioned earlier that you can share trackers. On the right, this is how a shared tracker looks to the owner. On the right, or I'm sorry, on the left, that is from the takeout data. What happens is it simply adds the recipient's email address to the creator area of the JSON entry. And so you can see if I had shared a tracker with like 5 different people, you would have 5 email addresses there, plus mine as the owner. And that just shows you who can see information about this tag, including the location. If you share a tracker, again, it's in the takeout data, but on the phone, you will actually find some information about shared trackers. 1_threads.notifications, you're going to find this database peppered throughout the Android file system. They're all over the place. But the one that we're after is the one that actually sits in the app sandbox for the Find My Device app. I've highlighted the thread ID column value, and that's because it's got the word sharing in it. So if I look across that record, I have a rendered message column that has a protobuf blob in it. If I decode that, I can see that up top in the red box that a device was shared, and just below that I can see Pebblebee clip is now shared with HR Philby. I now know what was shared and who it was shared with. The green box at the bottom has got another Unix epoch timestamp. That is the time at which the tracker was shared with the recipient. So that's it for the owner's phone, but let's talk about the target phone or the victim's phone. Now, a victim is probably not going to know that they're a victim until one of 2 things have happened. One, they may find a physical tracker within their personal space, right? Think about things like I'm cleaning out my car and I find one, or I'm cleaning out a handbag or a gym bag, or I've sent my car to the mechanic to be worked on and they discovered it. But another likely scenario is that a victim's phone has given them a notification that there is an unwanted tracker following them. On the left, that is a screenshot from that S23. On the right, for the same tag, basically for the same session of that tracker following me, that is iOS on the right. That's my personal iPhone. I got these notifications a lot during this testing. My wife got a ton of notifications, and she really hated me after like 2 weeks. It was, I mean, she got tired of it, but she was a willing participant sometimes, and so she was a really good sport about it, so thank you, dear. But yes, we were both getting notifications. We would go out with friends, they would get notifications, and I would have to explain, yeah, I've got these things on me. Anyway, so on the left there, getting back to the Android device, a user simply just clicks on that notification card where it says more info, and this is the flow that they're walked through. On the left, a map is normally rendered, but here the map didn't render because I had very poor cellular service or where I was at the time. If I want to get information about it, I go to that next steps button, and that takes me to the window in the middle. You're given some instructions on how to get that tracker into a state to which it can be scanned. So for the Pebblebee clip, I have to triple click that button that I mentioned earlier. It gets into a state that it's able to be scanned. The phone picks it up, and then it opens up a Chrome browser window, and you can see there on the far right, I've got it highlighted. I've got 2 things that you may have seen before. I've got a device identifier and a redacted email address. For iOS, that flow is very similar. You can see on the left, that clip was following me around to different locations, and then I go through the process of getting instructions on how to get that clip in a state that I can scan it. Once I scanned it, Safari opened up, and I get basically the same thing, but actually I didn't. And that's because the device identifiers are different. Again, same clip, same session in which it followed me, and then 2 different identifiers. These identifiers are called ephemeral identifiers by Google. If you look at their developer documentation, it states that these ephemeral identifiers are only good for 5 minutes. So as an investigator, if I have a victim come to me and say, hey, I got this notification, I scanned this tag, and it gave me this information. If I wanted, as an investigator, to rescan that tag, I'm going to get a completely different identifier. That's okay. That's part of how it works. So long as you've got at least an identifier, you can send that to Google to get information about the clip's owner. Remember, if you don't if you don't take anything else away from this particular, or from this talk, just remember this. Just because a phone has not thrown a notification to a user doesn't mean it hasn't seen one. So if you're interviewing a potential victim and they're like, well, my phone hasn't really said anything, but I think I'm maybe followed, definitely get an extraction of that phone. That phone may have seen it, they just haven't received a notification about that. And that's really important, especially when we're talking about Android devices, because this database, Personal Safety DB, keeps information not only about trackers that it has notified the user about, but also trackers that it's just seen. The first table here that I've got displayed here is scan. This is the table where you get information about the seen trackers. And so if I were to kind of expand that for you, I've got the MAC address, I've got the timestamps, but the real important information is in that column location scan it. It's a protobuf blob. So when I decode it, I get three things. In the red, I get a latitude. In the blue, I get a longitude. And I also get a timestamp that you see in the green. Now, I don't have it highlighted here, but the value at 0, 1, that's actually a horizontal accuracy in meters. If I take those lat longs and I map them out, that puts me at Sky Zone, which is a trampoline park for children in Apex. And I will tell you, at that time, I was in that location with my son with the Pebblebee clip attached to me and the Galaxy device in my back pocket. So the location is very accurate, as was the timestamp. Personal Safety also has another table, device data. This table has information about notifications that have been sent to the user. You get the MAC address, you get the time that the notification was created, but the interesting thing about Find My Device trackers is in this highlighted box, optional device data. If you remember the ring key value that I mentioned earlier in the takeout data, the ring key is actually sent to or actually is picked up by the Google device. I didn't have to do anything to the tracker or the phone. It automatically sent the ring key to my phone. And again, semi-quasi type unique identifier. I have seen them rotate. I just haven't seen them rotate very often. I have a ring key currently that's been static for over 3 weeks now. So in situations where you have a suspect identified, if you can get their takeout data or you have enough probable cause to get their cloud data by way of search warrant, I would recommend go ahead and getting that right away. It could be a quick win for you as far from an investigative standpoint. And again, I'm just kind of reiterating what I just said. They are randomized, but they seem to have a longer shelf life than those MAC addresses. So if you can't get the cloud data, make sure you can go ahead and grab it. So we've been talking about Android devices up to this point. Now let's talk about iOS, because again, as of 17.5 for both iOS and iPadOS, devices on Apple devices can now detect Find My Device trackers that are following them. And traditionally, what we know about AirTags actually helped a little bit with the research on the iOS side. If you're not aware, AirTags have a code name, Durian. Find My Device trackers and other third-party third-party accessories actually have their own code name, Hawkeye. Normally, we automatically assume that we just go to the unified logging, right? Unified logging can have location data, timestamps, and other information about an AirTag or a Find My Device tracker. But the problem with that is that Apple has redacted all of this information out of unified logs. So you see, I've got private and a set of brackets, so that's actually how it looks in the unified logs. Now, I've got a notation here about the AirTag developer profile. I'm just going to go ahead and say that it's very impractical for several reasons. The first is that if I install the developer profile on a victim's phone, it doesn't unmask previously redacted data. So that's pretty much out. And even if you've got a user that's savvy enough to do this, the profile actually expires after 5 days. And so they would have to constantly reinstall this developer profile in order to make that information available. But not all is lost. But real quick, I just want to show you how this looks to an iOS user. Working backwards from the time that I got the notification, I pulled a set of unified logs off the phone that had the AirTag developer profile on it. And you can see I found the entry in the logs, and I've got a big blob of data there at the bottom. And so blowing that up and kind of separating that for you, There's 3 bits of information here that are really important. The blue box at the bottom has got all the metadata about the tag, the make, model, product identifier, which is unique to Pebblebee. And in the middle, I've got a triggered date and time. That was the date at which the notification was triggered based on the behavior of the tag. But the really important part is there up in the red box. That is the location data for where the phone was when it saw the tracker. So latitude, longitude, horizontal accuracy, and timestamps. Lining that up with how it looks to a user, and I've added an additional color here, orange. Orange is highlighting the first seen time. So this is the time at which the phone first saw the Find My Device tracker follow me. Again, this is coming from a phone that has the developer profile installed. But what happens when that is not there, which is most likely what examiners and investigators are going to run into? As I was putting together this presentation, literally the day this thing was due, I inadvertently discovered that this information about Find My Device trackers that are unwanted is actually stored on disk in iOS. It's encrypted, but it's there. I also discovered how to decrypt it during this process. And so that kind of spawned this new avenue of research. And so I'm not going to be in a position to kind of disclose how that happens today. I do have a blog post coming about it though. But I do want to show you what the information looks like. It's in an encrypted binary plist, and just kind of lining this up with how it compares to what you see in the log entry. Using the same color coding scheme. Green, I've got the trigger date. Orange, I have got the first seen date and time, and then the red box contains all the location data, and it can be a lot, depending on how often that phone saw the tracker. If I scroll past all of the location data and get down to the bottom of the plist file, there I've got all the metadata about the Pebblebee clip. Same thing that I saw in the logs. And again, this is coming, this does not require the developer profile in order for you to render this. You just have to decrypt it. And again, working on a blog post and some additional research because it has other effects for at least what I know about iOS. That's all I have. Thank you for your attention, and I will take some questions.